Alright, so I asked you to do questions 2A and 2B. Analyze the worked example for multiplication of 3 binomials. So essentially what you're doing is you're doing a method called FOIL, or the box method. So x plus 2 so my box has a width of 2 because I have two terms here, x and positive 2. And then you take 3x minus 2 and you put it on the side. You're going to multiply first, and then you're going to add like terms. So 3x squared positive 4x and a minus 4 is your answer from here. So you have multiply those two. Now you have to multiply by 4 plus x. Same thing, multiply, and then you're going to get this polynomial. So now, since we've analyzed the work, use a graphing calculator to verify graphically that the expression in factor form is equivalent to the product in the ring form. So basically, you're going to put this here in yellow into your graphing calculator. And then I'm going to do the same thing with one in pink. And we're basically going to show that they are equivalent expressions. So put in our calculator. 3x minus 2 and 4 plus x, and then down here that's the factored form, right? Factor means it has parentheses, and down here I'm going to write the standard form, so no parentheses, descending order by the exponents, so x to the third, x to the second, x to the first, x to the 0. Notice my graph is on the center, so I'm going to take away these x values here, and I'm going to shorten up my y max. So I'm going to like 5, let's go -8, ones, -10, 0. A little better. You need to stretch it out more. So higher y max and a lower y min. There's my graph. Let's go ahead and sketch that. I'm not using a colored graphing calculator, but basically if they were two different graphs, then they're not equivalent. But because you see two functions, 1, 2, and you only see one graph, it's on top of each other, which means it's the same exact graph, which means it's an equivalent expression. So let's go ahead and graph that. And because I actually taught you guys how to graph this by hand, you can do it. This has a multiplicity of 1. If you solve this, you put them equal to 0. You're going to get x equals -2. So down here is -2. 3x minus 2 equals 0, so 3x equals 2. X equals 2/3. So here's 2/3. 4 plus x equals 0, therefore x equals -4. -4 over here. This is a cubic function, so they call this your leading coefficient because this is positive. In cubics, start down, end up. And because the multiplicity on these are all 1s, can't use pink, use orange, they're all 1 up here. That's odd. Odds you shoot through. So you go through, go through, go through. Okay. Answer the question below. Will multiplying 3 linear factors always result in a cubic expression? And the answer is yes. Because a linear is just x plus something minus something, x and then an x, so you basically have x times x times x, which gives you x to the third, and that is cubic.